Let us see what exactly the types of satellites and how Indian remote sensing satellites are actually evaluated over a period of time. You can see here IRS-1C, and of course prior to that IRS-P2 and 1A, 1B, of course not vogue now, they are all now obsolete, rather are extinct, they are not there anymore. LIS-1 and LIS-2, linear imaging self scanner is the name of the sensor. 1 and 2 were there, and you can see the resolution 72 meters and 36 meters, and it contained 4 bands, visible spectrum to near infrared. We had a P2 satellite, LIS-2 is the satellite, and LIS-2 the sensor rather. You have 1994, IRS-P3 1996, IRS-1C, one of the best satellites known, and we also we had LIS-3 from, you can see here, 72 to 36 meters, it ranged from 23 to 70 meters. So, that is the best part of it, isn't it? Then we have a very important namely the panchromatic which had a 5.8 meter. So, in the same satellite we had 23 meters, 5.8 meters. You see here there is another sensor called as WIFS or wide field sensor, which had a resolution of 188 meters. Just imagine, same satellite acquiring information about the earth's surface, one sensor acquiring 5.8 meter, another sensor acquiring 23 meters by 70 meters, 2 different types, and then you have WIFS acquiring the same area 188 meters. So, imagine what could be the total area of coverage by the satellite and what could be the total volume of data which is received by the earth station, isn't it? Similarly, we have other satellites also. Another satellite very important, namely IRS-1D satellite launched in 1997. Similarly, LIS-3, your PAN data and WIFS data. Of course, once advent of various technologies, and we find that resource satellite we call it as LIS-3, same LIS-4, WIFS. In 2002, they started using what is called as Cartosat with a panchromatic width of 2.5 meters and the swath width of 30 kilometers. I was telling you continuously the swath width is in the width of the area covered by a satellite, and you say find that it is 30 kilometers. From 170 kilometers, 188 kilometers is dropped down to 30 kilometers, and the resolution is also dropped from say 5 meters to 2.5 meters. Of course, we also have satellites. Next one, in 2003 they have launched another satellite, Cartosat 2, where you have 1 meter resolution, isn't it? It's an excellent aspect, isn't it? So, the most important thing is that we have now satellites which are capable of observing what is present in within 1 meter from an altitude of say 200, 300, 500 kilometers. Isn't it amazing to know how to get the data and how difficult it is to get the data, and once you get the data, what am I going to do with the data? So, the data is obtained by various satellites by different countries, and incidentally when you look at the calendar, you find that at least any one satellite will be hovering or going around the earth's surface at any point. So, we do not bother about a specific land or particular application. Any satellite, if Indian satellite is not there, a foreign satellite will be going around India, and if we request them, they will be giving or providing the data to us. Apart from the government agencies which are using the satellite, which are launched the satellites, we also have private agencies which are doing things. So, GeoEye, one of the leading satellites which are providing the data even to your Google. So, whatever you see on Google Earth is nothing but from GeoEye, a very important satellite, and it is being received and it is being used. This is what is about the various satellites and how the resolutions have improved from say 170 meters to 1 meter. So, that is what we normally use. Now, here let us see one simple example of how satellites are capable. I was telling you about the WIFS, isn't it? Wide field sensor or WIFS otherwise called as. Now, it had a huge resolution, or rather in our context is a small resolution, in the sense it was covering 188 meters rather, and you can see the entire country is mosaicked as a single image, the entire country, India, of course obviously we also get Sri Lanka, and you find we are able to mosaic them as a single unit. Just imagine getting or understanding what is present for the entire country at any given time. Of course, the satellite may be having a different period, but still they are all put together as a single data and then provided to us. And you can see that what does it indicate? This area, obviously this area all of you know your Jammu and Kashmir area ice covered or snow capped. Hence, we have the white color snow, we have all red color indicative of your vegetation, isn't it? So, very important. Why is it red in color? I was telling you about the band data. We are using green, red, infrared, and the bands available are green, red, infrared, and the filters available are blue, green, red. So, when I apply the blue, green, red filter on the green, red, infrared, obviously the resulting color will be, vegetation will appear red in color because we are using infrared. So, we have the vegetation shown in red color, light white color, obviously irrespective of whatever could be the possible color or band. When you have sand, if it is not affected by say moisture, it will be white in color, light in color. When you talk about vegetation or areas which are devoid of vegetation, so we will find it is bluish green in color. Obviously, when you talk about water bodies, it will be blue in color. Then you might ask me a question, sir, how about this? These are all also again water bodies, isn't it? It's nothing but because of the depth or the deeper nature of the water bodies, they all appear to be dark in color. Vegetation green, water body blue color. Water body will appear blue color provided it is shallow in nature. That is, water body, if it is shallow in nature, it will be appear in color blue, whereas if it is deeper, it will appear as grey, dark color or any black, sometimes blue, dark grey or black in nature. And what kind of satellites are there? How the various objects will appear? We have just seen that. Let us now see what kind of data products are available, which are readily available with NRSA, and how you can use that depending upon type of application. So, let us see them one. Now, data which is available to human your applications is your photographic in nature. It could be black and white, is nothing but your panchromatic, and you can get a contact print. It could be a false color composite or FCC, otherwise I told you. You can get as a transparency, you can get as a contact print, or you can also get it in the form of a say digital data. We will see that later. Then we have very important data, namely geocoded special products. So, when you talk about a false color composite, these false color composite are nothing but representing a small area which need not be representing a latitude, or it need not be referred to any coordinate system. When you talk about geocoded, as the name indicates, geocoded with reference to a specific area coordinate system, that data will be provided with the latitude, longitude, or your UTM coordinate system, which we already seen in say geographic information system, where about coordinates and the system. Now, when you have the geocoded data, we will be in a position to know where am I, and I can work with that. When you have a normal false color composite, we will not be knowing where we are working, because we will be just getting data about a specific area. But when it is geocoded, we will be knowing the latitude, longitude, we will also know where exactly we are working. Now, we also have what is important, otherwise called as your digital data. That is, it is not necessarily that you should obtain the data in the form of say hard copies. We can also obtain the data in digital nature. In fact, majority of the applications now, most of us are using only digital data as far as satellite is concerned. Hence, I thought we can also have a detailed discussion about how data is digitally enhanced, digitally modified, digitally monitored to obtain information. See, what is the ultimate aim of remote sensing? To acquire information about the Earth's surface, isn't it? So, in that context, we will be using digital data. So, the digital data normally available normally your computer compatible tapes, of course, not much use now. Of course, we also have 5 GB or 10 GB tapes. We have a normal routine utilization by your general public, CDs and DVDs, and sometimes in cartridges also. So, any of these formats you can get the data, and we can use the data according to our requirement or study. So, let us see one satellite data, how a satellite data will appear, and what kind of course, we have seen the entire country as such. Let us see how a satellite data appears. You can see here, this is a typical FCC, otherwise called as your false color composite. It will be impossible or near impossible for us to identify the objects in terms of, let's say for example, whether it is a building or other detail, but some of the characteristic features are what we called as the interpretation techniques will help us to identify. You can see here how beautiful vegetation is appearing red in color here. This is nothing but the greener the vegetation, the brighter will be the values. In some of the places it is not that very bright, though it is red in nature, it is not that very bright, indicating the vegetation may be sparse there. And very obvious, you can see here, this is a typical water body. How a water body will appear in a satellite image here, and you will find that because of the depth or the deeper nature of this particular water body, it is appearing dark in tone. But the same thing, if you just see inside somewhere here, it will appear relatively blue in color, indicating it is shallow in nature. Now here, this water body is nothing but a river. Of course, all other things I just told you, it could be urban area or vegetation areas which are devoid of vegetation, and this is your urban area. Because the scale of this particular image is so small, I am not able to decipher anything. I can only say in the given image, this is your urban area, a part of it is this urban area, and you can find a small or a faint line here. Definitely the resolution of this particular satellite will be much coarse, in the sense it could be 30 meters, 23 meters, but still you are able to identify a bridge here cutting across this particular river. How? Because of the linearity. So you should understand that remote sensing will not only help us to identify the objects, but also help you to interpret the object. So we sometimes identify based on your knowledge, many times we interpret based on the indirect method of understanding how the objects are present. So invariably we interpret the satellite data for various applications. When it comes to large scale satellite data, namely I was told with a good resolution 1 meter, we need not do much of interpretation. We simply identify the data, because we will be in a position to see the objects as it is, isn't it? Good example is your Google data. When you talk about a small scale or a larger smaller resolution, we will be finding more of area covered and less of detail obtained, but still application part of it. For example, simple example I will give you, water resources. If I am interested in knowing what are the water bodies given in the city of Chennai, I cannot go for a 1 meter, isn't it? Because I cannot handle such a huge data. I go for say 23 meters or 36 meters or 30 meters depending upon the satellite, and then I try to understand, because my application is only to know where are the water bodies which are present in the city of Chennai. I need not bother about other things, because it will also help me to quantify the data, calculate or measure the area each of the water body which is occupying on the given surface, and try to understand that. But at the same time, if I am planning for something like a expansion of a urban city, I cannot use your 30 meter data, I will have to go for 1 meter data, isn't it? So only then I will be in a position to understand what are the various roads which are present, where all you have vacant land, where all you have built up area, and so on and so forth. Of course, in that context, in a 1 meter resolution data, water bodies will be appearing huge, isn't it? Another good example of how use satellite data to our best application. For example, you see the same area, one particular area, namely the application is something like say disaster assessment. Here you find area is the same, but data is date is different, January 6, 1991 and April 28, 1991. In a span of 4 months approximately, you find there is a huge difference between these two data, isn't it? When what I see here, I know that, see, this is the curvature here. So the same curvature here. I find nothing but a little of say water or bluish tone and lot of sand here. But you see here, there is a huge difference here. Can you just imagine what it is? It is nothing but oil spill in a Gulf country. So during 1991 nothing has happened, that is your January, but after January 6, somewhere during maybe end of January or month of February, you find an oil spill has taken place in the waters here, and the oil spill has automatically come closer to the, because of the washing the movement of the water washing ashore of this oil spill, and it is affected the entire land surface in this area. So this is what we call it as disaster management. It is not that we cannot do with other methods, but this is the best method. If you want to identify or if you want to survey the area, it will take ages together, whereas it will take hardly a couple of hours to identify what is the area affected by the oil spill, to what extent, namely the extent of the area, and then we will be in a position to decide what exactly or what kind of action one has to take. So this is about general simple application in disaster management. Now coming to the most important thing, in the sense how the satellite data is enhanced or is monitored or it is manipulated to understand what is present on the surface. We call it as digital image processing. Let us see step by step how it is present. Various steps are there, about 12 of them. Let me say, first one, first we should decide what could be the objective of the study. What am I going to do with this satellite data? If I define the objective, I will be in a position to understand and identify that particular type of data. For example, if I am understanding or trying to work on, say, the barren land which is present on the earth in a given area, I cannot take data which is somewhere in, say, cloud cover or somewhere during the rainy season. I will have to take the area or collect the data of that particular area during dry season. Only then I will be in a position to work on the barren land capability, isn't it? So, that is the reason we normally decide what is the objective of the study. Once the objective is fixed, we can decide what kind of data you have to procure. Then we have acquiring of the data based on the objective. Then very important, assess the data quality. So, when I say data quality, most important thing is the cloud coverage, because visible spectrum is not capable of, underline that, visible spectrum is not capable of reflecting beyond the clouds. Hence, whatever energy which is coming through the atmosphere gets reflected on the clouds and you will find the clouds on the image. So, we will have to decide what is the quality of the data. So, invariably we will say 10%, 5% is the cloud coverage acceptable to my application. Sometimes even 10%, 5% may not be acceptable, because when I am working on something like urban infrastructure, I cannot accept even a small stretch of land which is covered by cloud coverage. Hence, in such cases we look at the data, decide whether we can go for another data or another data for that particular area which is affected by, say, cloud coverage. So, third thing is you are assessing the data quality, then correcting the data. As I was telling you right from the beginning, satellite data, it is capable of acquiring the reflectance energy and then dumping the data in the form of digital numbers in a station which is received by the, which is present on the earth's surface. It is received, it is stored there. Now, the data is a raw data, it will not contain any other data, it will just contain numbers, as I told you, 0 to 255 levels or 0 to 127 levels or 0 to 63 levels. So, what does the number indicate? How am I going to work with that? I will have to correct the data. I told you earlier, radiometrically data will be affected, geometrically data has to be corrected. So, correct the data either radiometrically or geometrically. Then we have to enhance the data. All the data what we see or what we receive from the satellite may not be reflecting or may not be giving the exact detail. Hence, we have to enhance the data. We will see one after the other. Then correlate the data with the ancillary data. So, correlation, because when I am looking at something like a large area for agriculture application purposes rather, wherein which I am going or interested in, I am going to look at areas which are green in nature. If it is a small area, then I will go for a larger scale. If it is a larger area, something like state of Tamil Nadu, I have to understand what kind of vegetation is present where. If I look at it, state of Tamil Nadu, if I am looking, I am not going to see only one type of vegetation, I will have different types of agriculture products, isn't it? So, in that context, I will have to see what is the type of vegetation present at which part of the state and how am I going to identify that. So, for example, if I am going to identify all agriculture lands which are comprising, say, paddy, then I will have to work on that particular area. For example, in Tamil Nadu state, all of you know it is Kaveri. So, the Kaveri delta which will contain paddy, total area will be mostly paddy in nature. So, I will have to correlate that particular data, satellite data, with ancillary data, that is the ground data. Only then I will be in a position to know if it is going to be paddy, because as I told you, everything will appear green in nature, whether it is going to be pallet, it is going to be millets, or it is going to be your paddy or your wheat, everything will appear green in color. So, I will have to correlate the data with ancillary data, only then I will be in a position to identify what type of vegetation it is. Next step is say select the training area. Now, I have identified the object. Now, I will have to make the computer to understand this particular piece of land is agriculture. If I am specific, I will have to say what kind of agriculture produce. So, that is training the area, that is making the system to understand this area is agriculture, this area is water body, this area is barren land. So, we will see that step by step. So, once I get the train the area, I will have to determine the spectral characteristics of that particular training area. I am going to say, for example, if I am going to look at this particular land, I have trained the land, I will have to know the spectral characteristics. Once I understand the spectral characteristics, I will be in a position to understand and classify the data. So, the next step is to classify the data. Next is very important, how to evaluate the classified data and then refine. If we find that the classification is not unique, it is not great in nature, I will have to refine the training and reclassify if necessary. And obviously, finally, I am going to communicate the results to the user or the end user rather. So, this is the way satellite remote sensing is analyzed digitally, and finally, we come out with a product which is useful for that particular application. We have just seen what are the various steps which we have to use or utilize in understanding the digital satellite data. Let us discuss what exactly are the steps involved in processing of satellite data. How are we going to use the techniques which are available to us to understand what is present on the Earth's surface in any given area. Let us start with the color analogy. I was just telling you earlier classes how we will be working on the colors. Very importantly, please bear in mind, the bands are different, colors are different. When I say blue band, it does not indicate blue color, it is the spectral width in blue, 0.4 to 0.5 and so on and so forth. Let us see about the color arithmetic. When you have colors blue, green, red, I was telling you, and all of you know that there are only 3 basic colors. There are no other colors, all the other colors are combination of these 3 colors. When I have all of them reflecting 100%, you will have a white color. If a part of it is absorbed in different colors, then we will have, for example, red plus green will give you yellow, green plus blue will give you cyan, red plus blue will give you magenta. Of course, this is what the role of filters on the satellite data. When I talk about image display, I was telling you how the combination of these colors help you in understanding the objects. When you have all the 3 bands reflecting 100%, what will be the color and how will you be in a position to do that, understand rather. If you have all the 3 bands absorbing the energy, what will happen? Let us see that. A color combination of, as I was just telling you, red 255, green 255, blue 255, you will get white. The same combination red, green, blue all 0, that is maximum absorption, you will get black. But a little variation, red 0, blue 0, green 95, you get green color. Something similar to that, different types of combinations. See, very important, purple, blue 100%, red 100%, green 0, you get purple, cyan, grey. So, variation in between you are 0 to 255, around 170 if all of them are there, you get grey in color. So, you should understand that a color combination will decide what kind of application I am using, what is the requirement. So, let me come back to the next aspect, namely the different sensors and resolutions. As we have already seen that, just to give you trying to recollect what we have done. AVHRR, Landsat MSS, Landsat TM, spot all foreign satellites, various spatial resolutions 1.1 and 4 kilometers, swath width of 2400 kilometers, 80 meter resolution 185 kilometers, 30 meters 185 kilometers, 10 meters, 20 meters and 60 kilometers. These are all the bottom line indicating your swath width and the first line indicating your spatial. Of course, spectral, let us not go into detail, just to give an idea. And we talk about the radiometric, we talk about the 10 bit, in the case of your say AVHRR, because 8 bit is what is the maximum application, 10 bit as I told you 255, now it's become 10 bit is your 1024, 6 bit, 8 bit, 8 bit, most of them you can see is 6 bit. Initially Landsat had a 6 bit, now it is all 8 bit, and their temporal resolution, that is the number of times it will be passing through, 12 hours, 1 day, 1 night, 16 days, 14 days, 26 days and then 26 days. So, depending upon the type of satellite, the number of days it takes to cover the entire Earth's surface. Let us see the very important application or how we understand the data. I showed you one simple example how the con and other things will be behaving over the entire spectrum width. Now, let us see same area acquired from satellite, namely the Landsat satellite, and that particular satellite, how various wavelengths behave with respect to the particular area. Now, here visible blue, visible green, red, near infrared, middle infrared and then second set of middle infrared and thermal infrared. You can see that each of that bands are behaving differently at the entire or the same area. In particular case, this is your visible spectrum, you find that blue color, namely vegetation, I mean, so name blue color your water body, vegetation is the other side, blue color your water body is absorbing or reflecting to some extent, absorbing if it is deeper in nature. But when you come to the near infrared, you will find that vegetation is reflecting more and water body is also reflecting, but not to that extent. Thermal infrared, that is nothing but the re-radiated energy by that object, especially the absorbed energy is nothing but your thermal infrared. You can see that it is little hazy in nature, but still depending upon the application, depending upon the study, we decide which of the bands are important. Here, as I told you, visible green, red infrared is used mostly for all majority of the application. In some application, we will be using thermal infrared. I decide what is the application, I decide what is the satellite, I decide the type of band. Once that is decided, I obtain the data from the agency who are supplying the data in different bands. Invariably, we can get the data depending again whether I am going to use on say radiometrically corrected data or geometrically corrected data. If it is radiometrically corrected data, I will be getting the data in different bands, while supplying itself they will be giving in different bands. If it is geometrically corrected data for an applications on natural resources or infrastructure mapping and planning, we use the satellite data which will be appearing as single band, but it will be separation, like you will be having what is called as a geo-TIFF, that is the data will be geo-coded or geo-TIFF in the form of a TIFF image which you will not be in a position to edit, but you will be having the data as a single unit. But you can understand that once you are working with that in the later stages, you will understand what exactly we are doing. So, we will be getting the data either radiometrically corrected or geometrically corrected, and then we will be understanding based on the requirement what is present on which part of the area. You can see here satellite data, as I was just telling you here, band 1, 2, 3, 4, 5, 6, 7, where in which 1 and 2 we are not using, 3, 4, 5 we are using, and then I told you that we can data will be available in a particular say band, and we can stretch the data, we will see that in detail, and then finally generate a color composite if it is given or provided to us in different bands. So, spectral bands can be obtained individually as different bands to the user, it will be given. You can choose any of them, say 3, 4, 5, use the various bands. I was telling the filters, the red, green and the blue on various bands, and then obtain a color composite like this. If this is ulta, if I can bring this blue to second, green to third and red to fourth, I will be getting a natural color composite. So, we will be creating a kind of a lookup table depending upon whatever the application, and then we will get a color composite. So, imagine how important this sort of analogy in understanding that. If I want, I can use the data directly as an individual band combined or a composite map rather, or I can have individual bands analyze the data and then understand. Thank you.